Hello again. So this is revision 4 of my laser cut clock. I would have liked to do a side-by-side comparison with the old revision, but I had to disassemble it to build this one. I've only got so many bearings and bolts and stuff. The major changes here are the use of a bead chain wrapped around the sprockety thing rather than a string around a spool, and I'm also using a gear pair to drive the escapement rather than driving it directly from the weight and the string. You may notice that the pendulum is on the right in this version. That was because I glued the gears together wrong and had to rearrange things to fit. It's fine though, because each of the three shafts are equidistant, so there's a variety of ways you can assemble the clock and it will still work fine. The bead chain is from the hardware shop, Bunnings, and the sprocket is contoured to closely interface to it to provide some good grip. I did experiment with a few different ways of building a ratchet mechanism or some kind of pinch wheel to hold on to it, but they were all too fiddly. This system, whereby the chain wraps around and they both cross over on the side, provides enough grip for it to work well, provided the free end has a little mass on it such that it registers into the profile of the sprocket. If the free end doesn't have that mass there, then it's free to sort of skip off and then the whole cord goes zoop and drops down to the ground. And it also has a little cable tie there to add some separation between the incoming and the outgoing cord so that it doesn't guide this out of the groove and it slips off or skips. The 3:1 gear ratio between the sprocket and the escapement means this version runs for about 5 minutes rather than the minute or so for the previous version. In addition to dressing all the teeth on the escapement with a file, I also rubbed some beeswax on all the mating surfaces, including the gear, to smooth them out a bit. That seems to have a small improvement, make a little bit of a difference. There's two major problems with this design that I've found. I'm using cheapo 624 roller bearings along each of the shafts, and they are dimensionally perfect as far as I can tell. But the laser cut plywood is definitely not. So it cuts a bevel on all the edges, including the inside diameter of each of the wheels and gears, and that means that they don't fit perfectly well on the bearings, and there's enough play in there for the angular alignment that the gears can sort of go askew or rub together or jam. Because they're not perfectly perpendicular to the shafts on which they're running. And the other source of slop there is that the bearings are running on M4 threaded rods, threaded bolts, rather than a 4mm shaft. So you've got a bit more wiggle in there. And over time or due to rough handling, the gears can get out of alignment and things can slow down or stop, which is bad. So ideally we want all the gears and wheels and everything to be completely perpendicular to the shafts so they all line up perfectly. And I think one way of getting closer to that ideal is to use the laser cutter to put a pilot hole and then drill out the 13mm hole on the drill press to get better perpendicularity on those holes and a snugger, more consistent fit. The other main problem with this design is the fiddliness of the pendulum. It's highly sensitive to the weight distribution of the bob at the end. So you'll see that's two bolts held together with a cable tie, and the pendulum arm there is offset to the front of the wooden arm, and the bolts are offset to the back to sort of try to balance it out a bit. So I think the best solution would be to make the main arm hang directly below the wooden arm and to add a pivot that only constrains the main arm along the axis we're interested in, so slight imbalances won't matter that much. That's about it. I've pushed all of the OpenSCAD code and DXFs up to GitHub, so have a look if you like. You'll notice there's a gear-shaped hole in that big gear there. That's because when I was laying out the parts I discovered that I could save a bit of plywood by cutting the small gear out from inside the big gear, which is fun. But yeah, progress. Okay, bye.